Hello everyone, good afternoon. I'm Buchi, founder and CEO of Levo.ai, an API security company. And this is Kiran, security engineer at Coupang. And we are super excited to talk about eBPF this afternoon. Hopefully you all had good lunch and we'll make our best effort not to put you to sleep. How many of you heard of eBPF? Okay, that's pretty good. So yeah, the topic of the session is to understand how we can leverage eBPF to do better application and data security. And before that, let's just look at the challenges some of the enterprises might be facing today in the application and data security space in general. All these APIs, microservices, Kubernetes, all of us are familiar. APIs have been around for a while. We are building more APIs than ever today, I guess. And microservices, some of you might have seen the pendulum on the microservices being swung far too far. I've seen the worst case where like people were building one microservice per API endpoint. And Kubernetes has been getting a lot of adoption recently for the continuous deployment and operating several microservices at scale. All these technologies have been enablers for us to adopt continuous deployment and innovate at a very good pace that has been enabling the businesses to grow faster. But there is also the other side to it. When you wear a security lens, all these technologies have brought in new attack vectors. And as a security person, how do you keep up with this? And when the environments are so complex and so dynamically changing. And of course, now we are talking about LLMs and Gen AI applications adding to the mix. So the challenges faced by enterprise applications is basically lack of visibility into these ever-growing assets, whether it is APIs or microservices. It's like, how do you even know the continuous stream of these APIs and applications that are added by your teams and never-ending resources that are being spun up in the cloud, all this. And so you need visibility. I mean, you must have heard this several times, but I'll repeat it. You cannot protect what you can't see. So visibility is a basic prerequisite for any security team or security person to do something about this, to protect them, right? So visibility is a starter. So you need to understand all the ever-growing APIs, microservices, cloud resources, and databases that are being added, the serverless functions that are coming up, all of these things in the application and data space, you need to have visibility. But visibility alone is not enough because if you look at what a security person does, a big part of their job is actually finding all the assets that are out there and finding the vulnerabilities in them. And then the second part is actually remediating the vulnerabilities that are found and getting them patched in time. And for that, you need to know who the hell is the owner for these resources, who owns these services, who owns this database, who should I even contact to when I come across a vulnerability. So context plays a big role in the second part. It's like, okay, you understand the assets, you understand and you somehow find the vulnerabilities, but then without that context, you cannot do better risk prioritization. You cannot actually route the vulnerability to the correct person. So the inventory or the complete comprehensive inventory of all the assets in the data and application space, and then the context around them, which teams are using under which business application, those two play a big role. And this is what enterprises are struggling with, and several surveys are done that confirms the same actually. And visibility is not a new problem, but like I said, all these technology enablers, all these new technologies have made it worse. And if you peel the onion one more layer, why they have made it worse, it's like, I don't know, how many of you are using at least 4 different languages in your companies for services? Actually, if you haven't raised a hand, I would say, take a note and go and double check. The several companies use so many different programming languages. We are enabling the developers to actually pick the technology of their choice and build for the good because we want the businesses to grow. But that brings a lot of complex tech stacks. It's like if you look at the application landscape, you have several programming languages and different frameworks that are being used. Even if you have a dozen Kubernetes clusters, there is very high chance that there is at least 5 different versions running out there. Because we don't upgrade all of them at the same time to the same version. So the complexity has grown crazily with this, and which is what makes the visibility much harder. And nobody is sitting there inventorying or documenting all of this automatically. And developers don't have time for all of this, neither do they find it interesting. I'm a developer, I can attest to that. So apart from the tech stacks, we are talking about multi-cloud, AWS, Azure, Google Cloud, all these. Some people are going back to data centers. Everything adds up. All this basically makes the asset inventory and context problem super, super complex. And finally, the sensitive data. We all know we are all being tracked right now. Like as a consumer, you may not know how many vendors have your data, but if you are a vendor, even the vendors don't know how their end users' data is coming in and where all it's being processed within the network, at least to the extent that they should be knowing. And sensitive data has become another big need for people to actually have this deep visibility, because especially when you go to payment industry or health tech, you're dealing with very important PII, PHI, and all this sensitive data. So because of all these reasons, the visibility has become so critical, and that's where the eBPF came as a rescue. So eBPF stands for Extended Berkeley Packet Filter, for those who didn't know about it. But why is it rescuing? Like, why eBPF actually comes to the rescue? We'll get into some more details on what eBPF and how it works shortly. But at a very high level, eBPF is a kernel-based technology that's super fast and efficient, gives you unparalleled visibility into the applications and the data and the networking stack that's going on at the kernel level. And it's also designed to be super secure, because just like we discussed, we want to adopt new technologies, but we want to make sure we are not bringing in new attack vectors if possible. And it actually is super easy to deploy. Going back, if you have a lot of complex tech stacks, it would be difficult if you have to go back and modify all your applications, but with eBPF, you don't have to. You don't have to touch any of your applications. And then it's open source. It's embedded right in the Linux kernel, and it's also, there is like several open source projects built on top of it. So there is a lot that you can leverage out there, and there's big community backing it as well. So these all ingredients make eBPF a powerful technology to actually solve the application and data visibility and context problems that we just discussed. So let's go one more level deeper. Okay, how does eBPF work? Like, it sounds magical, and bold promises generally are like, you want to understand, you don't want to just take somebody's word for it, right? Like I said, eBPF is allowing us to trace a kernel. It's allowing us to debug a kernel without writing any kernel source code, without reloading any kernel modules, which was the previous generation way of doing anything in the kernel level. You have to write some kernel code, or you have to write some kernel modules and reload those kernel modules, which is very scary, could cause kernel panic, could crash servers. This is the new generation technology that came, where there's a virtual machine sitting in the kernel runtime that's allowing you to write programs to tap into the kernel power and execute them and dynamically debug anything at the kernel level without having all the downsides that the previous technologies had. So that's why it's very powerful. And there are some components like verifier and maps that I'll shortly get into, but that's in a nutshell. This is a virtual machine that's sitting in the kernel runtime that's allowing you to do powerful things. And you write programs when you want to achieve something. There are a lot of good use cases that have been built on eBPF recently. Observability, just observing whether it is network, system calls, like whatever you want at the kernel level. You can even enforce controls. It's not just watching. You can go back and actually modify the kernel behavior. You can block some system calls. You can block some file writing operations. And there are a lot of networking use cases, like some of the modern Kubernetes networking stacks are being built on eBPF. And then there is load balancing, like that you can actually do at the kernel level, like, think about the performance benefits that you'll get. So there are several use cases and a lot of open source projects as well. But it has gained a lot of popularity in the networking and security in the initial days. And recently, more and more projects are just springing up in the data and application space. So the networking and security, the use cases are a lot more popular, but now we are solving more use cases in the application and data space. This is just like, for those interested, going one more level deeper. Essentially, we write a simple program, eBPF program, that gets compiled into the BPF bytecode and gets loaded into the kernel. Now let's go back to the verifier component I was touching about, and also think about, okay, you mentioned very big words like kernel, debugging the kernel, dynamically, loading your programs. All sounds scary. And you're just talking about better security. Is it actually better security? So that's where let's see what eBPF has done while we are doing all these things that might sound catastrophic or dangerous. What they have done, what guardrails they have put in place to make sure we cannot actually shot ourselves in the foot. The verifier is a component that takes care of it. Every program that we write and give it to eBPF system, the verifier actually runs through series of checks and make sure that you're not doing something funny. It's like no memory access issues, no control flow bugs, no infinite loops. Make sure your program actually exits. And if anything doesn't check, your program is not even loaded. So that's how it's safeguarding the kernel and making sure that you don't do any funny business there. And that's why it's actually much more safe and secure and resilient compared to the previous models of kernel loading or kernel modifying this kernel source code or kernel modules. So yeah, you give the program, verifier runs through it, all checks out, then it gets compiled into the native code or with the JIT, just-in-time compilation, and that's when whatever data you're asking, whatever you're interested in, let's take some concrete examples. I'm interested in looking at all the new connections that are being created. You will start getting information about all the new connections that are getting created on that host. That data is passed back to the user program, and now you can do whatever you want with it. So that's how it works in a nutshell. Definitely check it out for those interested. So I think, this is the verifier part I was talking about. Security-wise, if you have concerns, the verifier is doing all the heavy lifting and making sure that the resiliency and the secure aspects of your programs are taken care. So to large extent, you can you can write some bad programs. Obviously, there will be bugs in the programs that you write. eBPF program is a program at the end of the day, and developers do cause bugs, but that's where the verifier kicks in and saves us to large extent. And finally, we are all used to this, blue screen of death or blue Fridays, and this we might have even seen some of these occurrences in the past. That's where eBPF is different, because you are not doing all those kernel modules, and you cannot cause kernel panic in this, or at least not very easily. You can actually safely roll out the updates to your program and all of these things. So that's an intro to eBPF and how we can solve app and data security use cases. Let me hand it off to Kiran to go deep into particular use cases, specific use cases.
Thank you. Hi guys. I want to just quickly run into like 3 use cases that I've built in my personal experience. So we'll start with the API discovery. As Buchi mentioned, like the APIs, nobody knows how many APIs are there. I've been a developer before a security engineer, so I could never answer that question. So the power of eBPF is that it's like language and platform agnostic. So you can easily build a program that can be deployed across your infrastructure seamlessly, and then immediately starts listening to the network level events, which basically you can capture all the HTTP request response payloads. The cool thing about eBPF is like you can also, like TLS generally happens at the user libraries level, OpenSSL kind of things. So eBPF has access to data before encrypting and after decrypting. That's how you kind of capture the clean payload. And after having the payload, you can send that, you can basically remove sensitive parts of data within the agent or within the runtime of eBPF, but export into like a central server where you can drive more context, analyze the data to detect basically classify the APIs and data that it's handling. This is a kind of an example of a, eBPF powered application. If you see like it is capturing like all the API endpoints. Obviously the post processing will take care of normalization, replacing the path params. And the main things that I want to highlight is like it can detect the metadata. If you see the first column in this table, PII, internet exposure, how API is authenticated. So that can basically drive a lot of the security kind of management around like you can prioritize API that are exposed to internet over the other ones when you're dealing with any issues. Like in app and data security, like APIs is the starting point where clients are calling. But as we discussed previously, like database inventory and classifying the data and understanding the dependency of the data between different systems is a major problem to achieve like compliancy and data protection. So eBPF can also kind of get into the SQL layer where it can capture all the transactions that are happening. It can identify like all the databases, like type of databases. So you can build a catalog. Then you can also kind of, eBPF is leveraged in kind of some of the use cases where how you drive like a microservice architecture where you make sure like one database is accessed by one service. So we can basically build all of that catalog, which can drive like security and as well as kind of the microservice best practice use cases. And this is a kind of a screenshot like in a Kubernetes infrastructure, how you can use a daemon set, that is eBPF daemon set, and how you can leverage it to build a graph of your services and data and classify them with the data powered by this daemon set. So another thing that I mentioned in the use cases is that I think in last 2 years we have seen like a lot of zero days vulnerabilities. So when there is a 0 day, like for example, Log4j happened, across the infrastructure you would have like hundreds of services using that. eBPF, we can leverage eBPF to understand the, like there is a package that need to be patched, but you cannot like do it in all the resources at once. So this is where eBPF can help us to monitor the package behavior, where it can detect like what kind of resources are being used by a specific package. Like for example, a logging library, it writes to files, but if it is making any other like network calls, those things can be monitored. That's how like you can prioritize like which infrastructure need to be patched first over the other one. There are other use cases. I think Buchi will cover this.
Cool. Thanks, Kiran. So yeah, I mean, we just touched on 3 use cases just in the interest of time, but there's several other use cases that are being implemented and can be implemented because of the generic nature of the eBPF framework, right? You can tap into system calls levels both in the kernel space as well as in the user space. Like that means practically any program that you write that's already running out there, without even touching that application, you can actually write an eBPF program code and go tap into it. It's like developers attaching their debugger. Usually they are used to do it in the IDE, but now the magic is you can almost do it to a running application with a very, very minimal performance overhead. So because of that, there are other several interesting use cases. Just in the observability or security observability itself, there's many use cases that came up. And there's some distributed tracing use cases, like there's projects that came up that are attaching, enabling distributed tracing for all the running applications out there to get performance and monitoring insights. There were intrusion detection systems that we can implement. And threat detection. The threat detection is a very generic problem across the stack in different layers, right? You can actually do the threat detection at the network layer, as a cloud layer, as part of the cloud security, and you can do the same for application or APIs. So all of that is being used. And then very interesting networking communication patterns as well, like you want transparent encryption to be implemented, that can be done. So there are some advanced networking use cases like microsegmentation or network load balancing, like I was saying earlier. So lots of use cases, and the last one is basically a function level monitoring. Like that's the package behavior monitoring use case that Kiran was talking about. It's like it profile almost every function that's out there in your libraries that you are using, and anytime there is an unexpected behavior, or go back to Log4Shell case where people were making network calls, like the attackers were trying to make network calls by leveraging the vulnerability in the Log4Shell. You can completely block network calls from Log4Shell library. So even if you're not rolling out a new fix, at least you have a mitigation in place. So lots of interesting use cases. Definitely do check out the projects. So yeah, so we covered in general app and data security problems. We looked into what eBPF is and how it works, and we looked at few use cases. Now how do you operationalize it? How can you run it? I think like Kiran touched on it. You can run eBPF sensor, the user space program. You can call it as agent sensor. Different people call it differently, but ultimately there is a user space program that you are writing. That is what is loading the programs and running, right? And that you can run on. You can run it as typically it's run as a daemon set in the Kubernetes deployments, running on every host. But you can also install it on regular VMs with the package managers like apt, yum, or any other. It can also run in the container directly, as long as it has the correct permissions or capabilities in the Linux terminology to actually see the data or see the system calls. It works. And typically people bake it into AMIs. That way, it's going as part of the continuous deployment. And in the cases where you don't have access to the server, you could even run it as a sidecar container. So as long as there is Linux kernel, you can run. And the beauty is, doesn't matter which language, which framework your applications are written in, and even if with TLS, it's working out of the box. And there is eBPF support for Windows in progress. Microsoft has been working on it. And here are some popular projects that might be worth checking. So Cilium is very popular. And I think the company behind it is Isovalent. Cisco acquired them recently. But Cilium is in the networking space. You can write networking policies to make sure you are shaping the network in the way that you want. And Pixie, I think this got acquired by New Relic, very hot in the observability space. Dynamically get performance data or even observability data from any of your applications. And this Tetragon and Falco, from Sysdig, they are up there in the expo. They have a booth. I think they are talking about this Falco right there. They have a book also, a nice book on the deep architecture of Falco. If you want, just go grab a copy there. And the final one is a project called Odigos. That I was talking about. They are starting to do distributed tracing. Usually, for those who are familiar with the application performance monitoring or distributed tracing, the previous versions needed for you to change the application and embed an agent inside the application. So that means you have to go and iterate through all the Docker images that you have if you are using Docker, or if not, also you have to go over all the applications and embed an agent. This is almost magical compared to that approach, because you're just installing something and you're not even restarting your applications. So yeah, and these are all open source projects. But let's also touch on, okay, it sounds very rosy and magical, but we should also know the cons or downsides. Typically, because we are talking about installing it on the machines as daemon sets, first thing, you need to have people with the right permissions to install this stuff. So some DevOps bandwidth and some monitoring and all of that is needed. Account for that. Not everybody can go and directly install it, right? In some cases, it needs the right Linux permissions as well to be able to look at all other containers and all that. So there's some management and DevOps bandwidth needed there. That's usually one problem that I see in some cases, especially if the project is driven from security standpoint, because we all know you got to go and borrow the bandwidth from the DevOps or SRE team for that. And then the resource, because it's running on every server, the resource usage counts. And not every agent is same, so it depends on the implementation, that user space program that's written, how much memory, CPU it's consuming, and can it go crazy and eat up way too much and all that. So you have to watch out for those. But luckily, Kubernetes kind of systems allows us to put limits, so you can make sure that there are limits for all these agents so that they don't hog your system's resources. And then management and upgrade. So although it's still safe, but still like you have to make sure you upgrade on everywhere that's installed and all of that. So these are the typical, not necessarily problems, but like some roadblocks that I have seen for eBPF based systems to be adopted. So the bandwidth and permissions generally comes in, and resource usage as well. I mean, people already have several agents running, logging agents and all these things. It's like the first reaction sometimes you'll hear is like, one more agent? Excuse me. So, and the last one, I think again, it depends on how the agent is implemented. The agent itself can be implemented in any language you want. Now, if you are implementing that agent in Go or any other languages and you are pulling third-party libraries, that's not eBPF's problem. We got to make sure that agent also does not have any CVEs or 0 days. And so those are usually the questions that everybody asks. But doubling down on the security risks due to eBPFs that I said earlier, there is verifier to make sure that your programs are not funny, but there could still be some cases. One is like the agent itself. If it is opening up any additional ports, again, that's not eBPF's problem, but it could be seen as, because the agent itself will be treated as eBPF agent. So opening up ports and, or trying to reach out to third-party applications or third-party websites, and some of this could be a new attack vector. That's something to watch out for. And I think there are some clever ways where, if somebody gets hold of your machine, they could turn off the eBPF agent or eBPF system capabilities in general. I mean, it's root can always do anything, right? So there are such scenarios, but in general, these are like very, very hard to get into, but nevertheless, you should still keep them in mind. So watch out for these, especially check the agent to make sure it's not bringing in any vulnerable third-party libraries and it's not doing any outbound calls or like reaching out to any insecure third parties. Yeah, I think that's all at a very high level.
Thank you, guys. Thank you, Kiran and Bucci. So we'll open it up to a Q&A session now. First question over here. Excellent.
How would you foresee this being abused? So I noticed you had something on there that, if this is installed, it could open up additional threat vectors. So could you talk about that a little bit?
Sorry, I want to make sure I understand the question. The abuse?
Yeah, so well, if you install eBPF on the server and it's running, how could that be, I would say, misused by a nefarious or threat actor?
Yeah, that's where I highlighted, if the agent is not reaching out to any other third parties or any other outside source, then yeah, if it is contained, then it is pretty safe. So I think going back, one of the diagrams that we have shown, the sensor or agent, whatever you call it, has two parts, right? There is kernel space, there is programs that you are loading into kernel space, there is user space program. Practically, that user space program is like yet another process or process you are writing, and that has nothing to do with eBPF. But you perceive it as a eBPF agent, right? So most of the issues that could go wrong could be in that user space agent is what I was calling out. And it depends on what you're doing there. You could do bad stuff, bad programming there, and that could cause resource problems. You could do insecure coding or use vulnerable libraries that could cause issues.
So in what you just described, it's possible to build eBPF agents that kind of filter in the kernel, send data up to user space, and then back down into BPF and re-inject?
Yeah, actually, yes. Capabilities wise, it's not limited. Like I was telling, the capabilities wise, it can even go back and block some system calls or modify the behavior of some of the system calls. So the capability is there. So it's up to you to decide how you want to implement and what the agent does.
And so, as you kind of mentioned earlier as well, kind of following up on that, right? So, traditional BPF is Berkeley packet filter, obviously, and that is really focused on capturing network packets. But eBPF is much expanded, right? So now there's APIs, there's system calls. If I'm not mistaken, Linux has deprecated system tap, or is planning to deprecate system tap in favor of eBPF. And there's also the storage subsystem layer that's now going to be exposed. So there's pretty much all the surfaces of Linux. And Microsoft, while the verifier and the API code points are the same, so the BPF programs, eBPF programs are somewhat portable. They're not all of the facilities that are available in Linux are available in Windows, but it exposes kind of pretty much all the subsystems of Linux. Is that right?
Yes, it's much broader compared to BPF. It even exposes the performance subsystem of the Linux as well. In fact, if you noticed in the slides, there is perf events as well, which are giving you visibility into the performance of the system calls, including the hardware. Like even if you have a CPU miss, CPU cache miss, you could get a perf event. So it's very easy to shoot yourself in the foot with the eBPF. Basically, because depending on where you are actually hooking, what your program is doing, you could be literally drinking from a fire hose. Your user space program may not even be able to handle that kind of data. So you're absolutely right. It's much bigger capabilities. It's opening up a lot more subsystems, but they seem to be convinced that this is the right way to do. So that's why they are opening up more and more subsystems for this.
So, but opening up those misses also opens up a timing side channel on most. So, I mean, that's how a lot of cryptographic loss, right? So, how you lose keys is by those kind of timing side channels for cache misses and your ability to then see where cryptographic materials are stored or, how those misses, et cetera, happen.
Yeah, I think, but if you think about it, the agent is not magically getting onto your system, right? That's where there is definitely some burden or some responsibility to vet what permissions, what Linux capabilities it is asking for. So the good news is, in a lot of these agents, we make the Linux capabilities that it is asking for very explicit. So you could even say, okay, you don't have capabilities to look at any file operations or performance operations. You are only limited for just socket system calls. So you could pin it down like that. So I think the power is there, but then you got to make sure you're not giving it too much power. So you can pin it down at the agent level when you're installing.
Another question?
Thank you. I have a couple of questions. One is a follow-up for that one. Questions. Is it possible to run this agent on non-root accounts, using non-root accounts?
Yes. Again, it goes back to the Linux capability. So their dependency is not on the user, rather on that whatever account you are running it as, that account or user having those Linux capabilities. As long as they are given, you can run it as a non-root user as well.
Yeah, because if you run it using non-root accounts, then we can actually limit the damage.
Yeah, no, typically that's how a lot of agents run. I think then it depends on that. In my experience, I have seen it depends on the maturity of the teams. Typically doing it as a root is very straightforward. You don't have to go figure out all those things. And depending on the maturity and time they have and all that, like some people do take those shortcuts, but the capability is there if you want to use it.
Okay. My next question is about the service mesh stuff. In AKS, ARO, we use the history of service mesh. Now using this, is it possible to set up kind of enterprise service mesh? Setting up these agents on VMs, setting up these agents on AKS cluster and ARO clusters. So that way everything can have one service mesh And that one mesh means we can control everything. We can easily implement microsegmentation.
Yes, I think that is the direction it is heading towards. I don't recollect the name. I think I've seen some efforts going towards that direction, but there is already, like I pointed, some use cases, transparent encryption. I mean, service mesh, a big responsibility of service mesh is do MTLS. That is already done by eBPF. That use case is already available, but there are other things like running some envoy filters, or like in general any filters, or doing some additional authorization. That part I don't know if they fully nailed it, but technically I think it's complete. That's the direction that I see.
Look it up, Cilium. I think
Cilium.
Cilium has these
Yeah,
capabilities.
that's what we have been looking at.
Yeah.
Yeah. Well, no, thank you everyone
Set.
for your time. Hope
Thank you so
learned
much,
something.
everybody.